Okay, so here's we have number 18 from 12a. So how many order triple of x, y, z are distinct non-negative integer less than or equal to a to decide these inequalities? So like when you look at the inequality option, like x, y is larger than z, like zx is larger than y, and y, z is larger than x, they're just symmetric, right? So which is why we can just take the maybe one of them and just do the case based on that, and then make this general statements after. Might be a good idea. And another way thing to look at is like since x, y, z they just have no priority, so you can just actually choose one unordered pair, and then you can just order after. So like let's assume that x is the smallest one, and then y is the second, and then z is the largest one. And as soon as we got the order pair of this, we can multiply this by 6, which means any choice that is not multiple of 6 shouldn't be the answer. And I just see they're actually all multiple of 6 anyway. Okay, so I think, yeah, they're all. So then now we can just kind of list that way. There are a couple ways we can list this, but what I'm going to do, I'm going to just do the cases based on the z, which is the larger one. So the larger one, if this is 1, this is 2, this has to be 3 at least, right? So that means the smallest I should start case is 3 for z. But in this case, this has to be 1 and 2 because we are trying to do different numbers. But it doesn't work because xy is 1 times 2, right? It has to be larger than that, which is not the case. So there's nothing for the first case. It's 0 out of the case for z is 3. And if z is like 4, so then I will just say, make sure we have this guy first. Xy has to be larger than 4, right? In that case, like we can try listing. And also we know that z is the largest one, x and y should be lower than 4. So you can have 1 and like 2, and 1, 3, or 2 and 3. So when you multiply, that's 2. It has to be larger than 4, so this is no good. 1 times 3 is 3. Product has to be larger than 4. It doesn't work, so that's going to be only 1. Okay, so far we have only one triple, which is x is 2, y is 3, z is 4. So I'm going to just say this is 1 so far, which is 2, 3, and 4. Okay, so and if I choose z is like 4, then xy will be, this is 5, will be larger than 5. So there's not many different options, so we can list that as well. So we can have 1, 2, and 1, 3, 1, 4, and then 2, 3, 2, 4, and then 3, 4. So the product has to be bigger than 5. So that doesn't work, that doesn't work, that doesn't work. So we have the other 3 does work. So it looks like we have 3 from here. And again, we can list if you want to. So the 2, 4, 5 is one triple, and 3, 4, 5 is another triple. So if you want to list that, which is okay. So 2, 3, 5, and then 3, 4, 5. Okay, so then next case is z is 6. And then we're going to do this all the way to the 8. So nothing too many options to do so. So if that's 6, so we will get x times y is larger than 6. So you can kind of list everything as we did right here because there was not many options. But in this case, you can kind of skip the one that doesn't work. So like the product should be larger than 6. So we can not do anything with ones because 1 and 5 is just 5. So 2 and 3 doesn't work either. So 2 and 4 is the smallest one. And then you got 2, 5. And then we cannot have anything else because we have to do lesser than 6 for the other 2. And then you got 3 and like 4. And then 3 and 5. And then 4 and 5. So it looks like we have 1, 2, 3, 4, 5 pairs. And then for each one has like z as 6. So we can list that, but I'm going to skip that listing because no one is asking. So that's 5 option. And if I just go with 7, so the xy is going to be larger than 7. And the product is larger than 7. And also xy is going to be just anything that is lower than 7. So it could be 1 through 6. But 1 and anything doesn't work because 1 times 6 is 6. So we should get larger than that. So you got 2 and like 3 doesn't work, but the 4 is the smallest does. And then 2, 5, and 2, 6. And then you got 3, 4, 3, 5, 3, 6. And then that will give us 4 and 5, 4, 6. And then the last one is 5, 6. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 options for this case. So like you can do this slightly differently. Like you can say, like when you determine x, like z as 7, so you can choose x and y as 1 through 6. There's like 6 options. So if you choose like 6 choose 2, that's 15. And then from 15 possible pairs for x and y, you can just find the one that does actually not work because that will be lesser than the number that does. So you can just list the one that doesn't work and subtract from 15. So that will give us 9 as well. So you can do that, especially for when it comes to the larger values, which might be useful for the 8 as well. Okay, so let's try with them. So the xy has to be larger than 8. So I can just say like 1 through 7, there's like 7 choose 2 ways to choose 2 numbers for x and y. That will be 21, right? But of those, I just want to know which one doesn't work. So the one that doesn't work is the product is lesser than or equal to 8. So we can say 1 and 2, and 1 and 3, all the way to the 1 and 7. And then you got like 2 and 3, because that's 6. We should get larger than 8. And then 2, 4. And then we got 3 and 4, but that doesn't like, that does work. We just want to list the one that doesn't work. So 1, 1, 1, 2, 1, 7. We have like 6 right here. So 2 right here. that is 8 of these, right? So there are 8 of those pair doesn't work out of 21. So you got 21 minus 8, which is 13, are actually going to work out. So you could have done that in the case Z is 7, but listing wasn't too many, so which is why I did 9. But if you continue in this, let's say we have 9 or 10 even, you can do the choosing and then count it that is unwanted, so you can just kind of subtract from that. That would be easier to do so. But anyway, so we have like 1, 3, and 5, 9, and 13. So you got 22, and then that will be 27, 31. So there are 31 unordered triples XYZ. Like for example, if you remember, this was one of these, right? 2, 3, 5, or 3, 4, 5. Or you can take the like Z7, 2, 4, 7, 2, 5, 7, or 5, 6, 7, or in the last case, 1, 2, 8, 1, I mean, not these ones, 3, 4, 8, and 3, 4, like 3, 5, 8, and stuff like that. When you have those kind of the 3 numbers, if you carry the order, so you just have 3 factorial ways, so which is multiplied by 31, so you got 6 times 31, which is 186, which is choice C. So I hope that was clear. So that was just another case or problem. So it was number 18, so it was slightly challenging. I'll see you in the next video.